Okay. Stand from the mic. So what we do is sustainable design. And how we do it is by training people and working with people to develop those skills in sustainable design. And that really goes back to helping students in architecture school. And we're going to talk about that in a few seconds. But ultimately, why we do sustainable design is to change the world. We're past peak oil. We're getting past peak everything else. So those natural resources that we depend on are being depleted quickly. We know we're losing water on this planet. We're losing forests. The glaciers are melting. And we have evidence, clear scientific evidence, that temperature and CO2 concentrations in the atmosphere are increasing to unsustainable levels. And when we look at what we've done just in the last couple hundred years to our planet, it really gets scary fast. And so we have to do something quickly. We know that buildings can have a huge impact on energy resources and energy use. And we know that we can reduce the amount significantly in all of these categories by designing buildings smarter. But we have a lot of problems right now that we have to overcome. We have politicians who don't believe in climate change. We have NIMBYs who don't want wind turbines in their ocean view off of Cape Cod. We have challenges to photovoltaic production and cost of doing that in the United States. And with all of that, we have a minuscule amount of money being committed by the government to research and development in alternative energy. It's just amazing that these problems all exist at the same time. But I think we can change the world, but we have to think differently. We always knew that, architects had to be good at math. Well, not really. What they do have to be good at is thinking with both the left brain and the right brain at the same time. And so we've been working very closely with a number of institutions. Our work here at Tulane is a part of that we really love that involvement. But we're working with University of Virginia, where I'm an alum, and also Cornell, where a number of my partners are alums, and looking at ways to start students early thinking with both their right and left brains at the same time. So this is a program that we've been running with Cornell for a number of years now to get them thinking about integrated design. And the course objectives are pretty broad, but we've used some of the examples that come from our regular work. This is at Cornell, Warren Hall with SGH worked with us on this project as well, where we're converting this building from what was originally the agriculture school to now being the business school. Seems like every land-grant college is changing their buildings from. So anyway, Cornell's changing this into their business school. We've used a lot of BIM technology, but the main thing in this is that we use this as a model for students to examine alternate ways of looking at the envelope. And in this case, Haley Cohen looked at the windows and how they could be made more energy efficient and also better sources of natural light. And she did a great job with this, used a lot of analytic tools, DASIM, and other analytic tools, and looking at also how to extend the garden onto the building and use it as a way, maybe as a hydroponic type solution or other solutions that bring the garden onto the building instead of the ivy-covered walls in the traditional sense. How can ivy-covered walls be made more effective? And she made those presentations to my partner, Dan Kaplan, and Ilana Judah, our Director of Sustainability. And actually, she did such a great job, we hired her. We also had the students at Cornell look at another problem, which was looking at modern architectural masterpieces and how they could be greened up and made to be more effective in today's world. So that had a fairly heavy course schedule as well. But here's a couple examples. This was the Grace Building in New York, which many of you might know. It's a curved facade. And we had the students look at how that facade could be redone in a way that would enhance its environmental performance. And this student, for instance, came up with the idea of replacing the curtain wall glass with a glass with an integrated louver system sandwiched in between two panes of glass. And he did models, both physical models and electronic models. We looked at One Liberty Plaza, which is a great building downtown, but it is in pretty bad shape in terms of its energy performance. And this student modeled the exterior wall to look at how we could add sun shading and possibly modify the actual curtain wall shape to improve the energy performance and sunlight, daylight harvesting that we could achieve in this building. And then ran again physical models of that. We looked at Eero Saarinen's CBS building, the Ford Foundation building. This was a really interesting exercise. Of course, this is a great building, and so looking at ways to add louvering systems and studying other upgrades to enhance the energy performance and the light quality in that great atrium. And then finally, 1 and 2 United Nation Plaza, which is a Roche Dinkeloo project across the street from the UN headquarters. And of course, this curtain wall, as many of these buildings, curtain walls are really out of date and not performing well. How can we look at upgrades to those? And this student said, okay, let's see if we can't find a way to make them operable panels that can take advantage of natural ventilation in the building. So he ran a number of scenarios and showed what that also did to the look of the building and started to activate that facade as well, which is pretty wild and pretty interesting. And then finally, and you've seen some of this before, we worked at Tulane with the additions that we did here. And I think the key here is that the students were very involved in this process, as we've talked about before. But as this building hopefully moves ahead, it will really form the basis of changing the pedagogy of the school. That the sustainable features that we incorporated into the new design will become teaching tools for the faculty of the school and for the students to engage with on an ongoing basis. We even looked at this building and the ecosystem of New Orleans on a much broader basis, the site. We ran energy models. Some of this we did not include in the earlier presentation, so I wanted to make sure I showed you this. But daylight harvesting, and I know we had some conversations about whether this slot was going to get light all the way down. And looking at other systems in the building and finding a way to do a wholly integrated system for the building. Whether or not the chilled beams end up working, we've still got a long way to go. So I know some people were concerned and expressed concerns to me about chilled beams. But we have a lot more to go on this, but it is a great example of integrating the students with what we're doing. And we're very proud of what we're doing on a broad basis with a number of institutions, and look to continue that to further the professionals that are coming into all of our firms in the future. That's it.